Perfect. Good? Mm-hmm. Cool. Thank you very much for coming down here. I thought the weather is superb and you don't want to be spending too much time with me, but I appreciate it very much. So my name is AviCavale. I'm the CEO and co-founder of Shippable. And what we are, and before I go there, this was a conference that just ended on Friday. So this was a talk that I did on that conference. It was like well received, so I thought I'll repurpose the slides and just talk about it. And what this is about is basically, it doesn't talk about my service, it just talks about how we use Docker. And so you don't really need to sign up for shippable.com to kind of take away stuff from here. But if you do, I would be more than happy to support you guys. But this is basically about just helping other people do what we do on top of it. So
those of us who don't know what Docker is, can you just give us?
Okay, so how many people know about Docker? Few people? Okay, so I think I'll probably spend 2-3 minutes what Docker is. This conference was about Docker, so it was for 2 days. There were about 85 different talks, so probably we didn't go into Docker because somebody had already talked about it. So basically what Docker is the simplest way to explain what it is. It's containerizing your applications. So what that means is, so in the past, there were physical machines. So everybody used physical machines. They had servers and farms of servers. And if you went and raised money back in '98 during the dot-com boom, you raised money only for one thing. It was not to build the application, it was to build a data center. That's what you raised money for. Like people raised 10 million, 20 million just to go build data centers. There were tons of companies out there. Most of those companies don't exist anymore. There were a few companies that survived, SaaS and those kind of guys, but pretty much everybody else is gone. So that was physical capital intensive, 3-year amortization kind of costs, right? That's what people sold. Then VMware came into being, and VMware went out and said, look guys, it's pretty stupid to kind of go and buy all this physical infrastructure. Your labs and dev machines are being used less than 2 to 3%. Why the hell are you guys buying? And I remember at Microsoft, I worked for a long time at Microsoft from 2000 all the way to 2011. The first thing when we started a project was figure out how much of dev and test machines do you actually require. And that's all we did. And we sat down with IT and they gave us a list of things, 9-month lead time, 6-month lead time, and that kind of stuff. So VMware came and said, don't do that. What you do is you layer this virtualization on top of it. And so you can create many machines on one machine. So that suddenly solved some of the problems. It created a whole bunch of other problems, but it solved some of the main problems, which was capacity problems. And so lead time problems, all of that got solved. So what ended up happening is people started putting VMs on physical machines. And instead of going small machines, people started buying bigger and bigger and bigger machines because you could layer more VMs, and labs started becoming these big machine labs with VMs on top of it. Okay. Now the VM technology came because of solving one problem, which was how do I create another machine out of another machine which is physically present. So they didn't really think about the software. They only thought about how do I get more machines on a physical machine. So what they did is they went down to the BIOS level and they said, how do we cheat the BIOS and make it think like as though I have multiple machines? And that's where ESX, KVM, and all those things came into being. And so they basically created virtual layers on top of it. So that ESX layer made it look like as though there were more CPUs than what was actually available. And then you could actually install OS and you could create machines on top of it. And the virtualization layer managed how to balance those resources. And you hear this thing, which is noisy neighbor problem and all that stuff, where somebody starts hammering your machine. And even though you're on that machine and you think you have 4 CPUs, you really don't have 4 CPUs, right? So those are all some of the problems that happen. But the real problem was the operating system existed inside the VM, right? So you first create a VM and then you install the operating system inside it, right? So what that means is on a single physical machine, let's assume all those machines are running the same exact operating system, and I could create somehow 10 machines on that physical machine. I had 10 copies of Windows or Ubuntu running on it, right? So that's kind of pretty stupid because 99.99% of the operating system files are never edited. There are a few things, settings and INIs and those kind of things, but nothing else is touched. So now you just have redundant copies sitting everywhere. So that was the limitation of VMs. But that's the limitation that everybody has accepted because they said physical machines are cool. But then there are certain folks who kind of said that's not good enough. So we got to somehow move the operating system down to the physical layer and create virtual things on top of it. And you can create what we call as symlinks, or links of files that make it look like as though I have a file, but it's really not a file. So at that point, what you can create is a container on top of it. So what now you can do is, instead of installing 10 copies of Windows, or I don't want to use Windows, 10 copies of Ubuntu, because you can't do containerization on Windows. So if instead of using 10 copies of Ubuntu, you can basically now have one copy of Ubuntu and have 100 containers all point to the same exact Ubuntu. And when you want to touch some file, it will basically make a copy of that file into the container. So you will have local copy of that file that you want to touch, and the rest of it is all coming from a global copy. So that's what containers are. And now what ended up happening is, this was nothing new. Sun did this in 1991. And they actually tried to do it. They made it work, but it was so difficult for people to understand how to use this, it never caught on. And then Ubuntu kind of came in, and then they started creating this thing called LXC, or Linux Extensible Containers. I think that's what the expansion of it is, or Linux Extension Containers or something. So basically what they did is they created this container system. That's how Heroku was born. That's how a lot of companies like Cloud Foundry, Engineer, and all these guys run. And if you go and look at DigitalOcean also, they use some form of LXC to actually make this happen. So what that gives you is higher density on the same physical machine. Now, you do lose out on certain things like network and everything, because you're still using the same NIC card for all those containers, but there are ways to get around it. Now, the beauty of this container is it thinks, acts, and looks like a VM without the overhead of a VM. So you can do everything that you can on a VM. Like in Heroku, you can't SSH in and go and say, I'm going to run root commands on top of that Heroku container, because they limit you. But on Docker, you can pretty much do anything you want. It's a machine. And so you can run stuff, right? So what Docker did is, Docker is actually a pivot out of a company called .cloud. And .cloud was founded, I think 5 years ago or something, 2009, I think, 2009 or 2010. They were coming out of Y Combinator. Solomon Hykes was the founder. So they came up with this idea and saying that Heroku was already bought by Salesforce, and said there's a market for another Heroku, and then they went and created .cloud. And they built all this technology for making that PaaS work. So they were trying to build the next generation of Heroku. And they tried for 3.5 years, and they could not get any traction. And they had raised $10 million, and it blew up. And they were at a point where they were going to declare bankruptcy. And then at that point, Solomon, who was the founder, kind of came up with this idea saying that, why don't we open source all the technology that we have built? And he just wanted to give it away before he went and declared bankruptcy. That's what he was trying to do. And he just gave it away. And this was back in last year, around April, May timeframe. And I had met Solomon at that time, and so I was very impressed with what he was doing, and I was watching what he was doing. And then Docker was born in June of last year. And so they renamed the company, called it Docker, and they are still running .cloud as a service, but they don't care about it too much. And nobody knew what will happen with Docker. But right now, Google announced yesterday that they're going to be supporting Docker as a native container. So that's how big this has become. He is considered to be, he's actually on the list of Forbes 30 under 30 and all that stuff. So he's a very, very smart guy. And so they've created a new company called Docker. Pretty much Red Hat has announced that they're going to support Docker natively. Ubuntu 14.04 shipped with Docker. So the future of all containers is Docker.
How is VMware feeling about this?
I don't know. So I think so. This talk is especially interesting for that, because it actually goes after showing exactly what will happen to virtualization if this does catch on. So it's not about if it does catch on, it has already caught on. It's about a matter of time of when it's going to happen, and it's just going to happen. And so we are all kind of waiting for it. Now, Docker might not win as is, but what they did is they created a revolution that some container system is going to win. We don't know what, but Docker is probably at the forefront of this whole process. That's what Docker is.
Great. So how do you put that in the context of VMware? What is the comparative threat? Or if any, that this...
So actually, competitive threat is not just for VMware. Competitive threat is for all licensing companies. because now today what they were doing was they were selling you licenses for every single VM. If I say virtual machines need to have licensing on Windows or whatever, Ubuntu, then even though physically there were only 8 CPUs, I was still licensing all the VM licenses on top of it. And Microsoft had said if you had used Windows to do the hypervisor, then you don't need to pay licenses or something. But if for whatever reason most people are using VMware, they're paying Windows licenses on top of it. Now if I suddenly take that down, and then I say I have only one copy of Windows, and everybody else is running containers, it's not just VMware which is in trouble, it's also every company that actually makes money on licensing. That includes Red Hat. Because Linux is what is going to get hit first, and because Docker supports Linux natively. So Red Hat has gone and embraced that, and they have said Docker is going to be native to their whole infrastructure. They will figure out the licensing, but they've already said this is part of our ecosystem. Now that means virtualization is going to be under attack next. So you need to figure out whether, and Red Hat is a big believer of KVM, and they have basically said KVM will exist, but it's on the down sunset, and everything is about containers, and that's what's going to happen. And based on my prediction, I would say Red Hat will go to all these lab guys, back what VMware did 15 years ago, and then they will tell them, we'll cut your VMware cost by 80%. Do you want to use our software? So this thing is going to start this revolution of this. And I believe that because of this, on-premise will resurface, because there's no reason to go to the cloud anymore. And because I can now create infinite number of containers, assuming I have enough physical machines. So we just ran a test, 1998 IBM ThinkPad or something, which is the old machine that I had. It has like 128 megs of RAM. We ran 70 containers on it. On just basic boot to Docker, which is just a kernel level of OS. It'll just give you enough network and all that stuff. Yes, you can't run full-fledged apps on it, but I can run any cron job I want. So I can have a full-fledged monitoring system. I mean, we are running our monitoring for our service because we need a service outside of AWS. So we use that laptop to do monitoring. So that's how powerful it is. So you can kind of go back to that whole device level. Like there are 2 operating system companies that are being worked right on. One is called CoreOS. It's a 35 meg operating system, and it only runs Docker. So you go install that, you bring up Docker containers, and you are good to go. You don't need anything else. And you can do live patch of CoreOS without even bringing the system down. So you get 24/7 availability and all this. Awesome. So there's a lot of stuff that's happening, and cloud, the way it exists, will be redefined, and we are just at a very early stage of how we are thinking of it. Make sense? Any questions? No? Good.
One quick question for the non-techie guy in the room. So how does this relate to, or as you talk through this, we're running on a road. We're sort of interested to find out where Shippable fits into that as a, I guess, a replacement potentially to Semaphore.
Yes.
And then how, it sounds like Docker is an alternative to the road, or next generation.
I think Heroku will support Docker at some point. And Heroku will probably give up their container system, because if every developer is on Docker and they're all building Docker containers, the eventual output, if anybody is familiar with Java, the output was a jar file. And then the jar file could be put on any particular machine or a JVM, and then suddenly that would appear as an application. So now take that jar file, which was an application packager. This is also with an OS package on it. So it's a full container, and I can just dock it wherever I want. I can dock it on my laptop, I can dock it on Heroku, I can dock it on AWS Beanstalk, or I can dock it on a physical machine that is running CoreOS, which supports Docker. So everybody is going to start supporting Docker as a native platform. So where I can build all the container, and I can just say push my container to Heroku, and Heroku will just light it up. Today, the way you push to Heroku is you do a git push, or you do something like that, where they take your source code and then they package it, and then they bring up a Heroku container and dock it into Heroku Fabric. Now all of that will happen before you hit Heroku, and they will just dock a Docker container. Now how Shippable fits is exactly that Semaphore thing. Now Semaphore today is just doing CI, which is continuous integration. We started off doing just continuous integration, but the way we look at Shippable is basically this. So we are not about continuous integration, we are about continuous delivery. So continuous integration is just a step of your continuous delivery process. So if you think about software as a whole, source code is one step which starts with everything, and then you do a whole bunch of stuff to do a pipeline in order to actually get your software deployed to production. So that shipping lane is what Shippable is about. So today what we have is basically what you call as the CI product out there. And the way we thought about it was every single startup cannot go and solve world hunger in one shot. So the way you do it is you find a very clear niche, and then you focus on that niche. You basically create a product that is so compelling in that niche, so everybody starts adopting it, and then you start expanding to where you really want to be. So if you think about just CI market, it's a very small market. I mean, it's not really that interesting for VCs and all those guys to be in that market. But if you talk about application delivery as a whole, it's a very interesting market. So
I guess the CI market is, Artifactory and Jenkins and these guys.
Jenkins is just software, right?
So just tools, yeah.
Yeah, and it's just a tool. But the CI market is basically Travis and Semaphore, and I don't know whether one of them named themselves as Solano or something. I don't know which one it is. It used to be called something else. There are a whole bunch of people. It was a very noisy area. When we even started doing it, the first feedback we got from everyone was that, why do you want to get into such a noisy space where there is so many options, so many ways people do it? Why do you want to get in? And because we got in because our plan was slightly different than what we were really trying to do, and CI was just an enabler for us. Any other question? Cool. So yeah, we are founded Feb 2013 last year. We're 10 people right now, headquartered in Seattle. Marketing and sales is in the Bay Area. So that's how we were founded. We were part of Techstars last year. So we were in the Seattle batch last year. And that was August to October last year. So the big question is, why is AWS so successful? This is something that we pondered. And I pondered about this not because of trying to build AWS, it's because of what happened once we were starting running on top of AWS. So just to give you a little bit of background, when last February we were not on Docker. Docker didn't exist. We were not on anything. So what the whole epiphany was, if GitHub could use Git and build this billion-dollar business, why can't I use Jenkins and build a CI business? So that was the whole epiphany, because anybody who has used Jenkins, how many people have used Jenkins? Cool. How many people like the UI? So basically our whole thing was, hey, we'll do this Apple-esque UI on top of Jenkins, and we'll somehow create this product, we'll run this whole farm on Jenkins, and we're done. And I looked at CloudBees at that time, and CloudBees is still Jenkins UI. It's just provisioning is a little different, and then you go back to Jenkins UI, you have to install plugins, you have to do all that stuff, right? So I kind of said, okay, why don't we just do this? And the whole motivation was, I was using Jenkins when I was kind of doing a startup on Cloud Foundry. I was working on a startup, and I said, Jenkins sucks, I don't want to use this. And so we went into kind of like, if code is in the cloud, an app is in the cloud, why the hell is CI running on a machine?
Did you try commercial ones like TeamCity and other things?
I had looked at TeamCity and everything, but I kind of said Jenkins was what default everybody was using, and we said if 80%, 90% of the world is using Jenkins, there's a market for us to go build it. So we built a beautiful UI, and it was very easy to use, simple, no plugins, beautifully done. Spent a lot of time, all the way from January to March, all we did was UI design. And we came up with this beautiful stuff, launched it last March, and said, okay, let's go and see what happens. And it was on beta. We got about 800 customers in less than 4 weeks. So we went to all the Jenkins group and we just posted it, and it was just beautiful. We were running purely on AWS, imaged Jenkins, and we would bring up Jenkins machines and as and when people used it. What I realized was my scale of economies of scale was linear. That means every single customer, I had to spend the same amount of money to run actually the next service. It costed me whatever, $12, $15 on it. And then I kind of said, the problem was now it's another VM to manage. My operation cost started going up because now I have all these VMs. I had to manage 800 VMs on top of it. So even though my physical cost of buying a VM was the same, my operation cost was very, very different. So I started looking at it and saying, if I don't get any economies of scale, then why is AWS so successful? I mean, what does it do that is so beautiful? So we've spent a lot of time, and then what I realized is because of this. Because of everybody says AWS is successful because of what you can do on it. And what I realized was it was successful because what they don't let you do. And this is coming from my experience with Microsoft buying 5,000, 8,000 servers at data center. I worked for Kinect and Knowledge Services, 5.9 petabyte business intelligence system built on SQL Server. If anybody you ask, they say 100 gigs, 200 gigs, don't use SQL Server. I was using 5.9 petabytes on SQL Server. So we had experience on the structure, and we were kind of thinking of it. So the typical question people ask is that really a true statement? And what I kind of saw at that time was it was actually true. And to do really understand, you need to understand what corporate data centers are. So what corporate data centers are is completely heterogeneous environment. It starts from every single piece which is custom for an application. Think of disk speed. Think of RAID levels. Think of how network NIC cards are set up. Think about how is SAN, even on SAN, is it having fiber channels or is it having regular channels? So every single application is asking for a different way of how the infrastructure is actually deployed. An IT guy has no say in this. If he tries to say, I want to do standardization, some vice president is going to come and say, $5 million, I'm paying you, you deploy what I'm going to ask you to deploy, and you deploy. And now you have no standardization, you have to support all this stuff. So what happens is this. You can replace that dev with a CVP of group A and a CVP of group B, and they're going to fight. And the IT guy in the middle is just going to say, I don't care. If you want me to do this, this is the cost of doing this. I need this many operation people, and they have this calculation. If you need 10 servers, I need this many people and headcount and all the stuff starts. And this is what I did most of my time at Microsoft, negotiating with IT and trying to get these data centers working, right? So this was what was causing it. And the biggest thing that they do is no developer wants to do anything in the application layer, and they push the resiliency to the infrastructure. No application inside a corporate data center is built for resiliency, including Xbox. If there is an earthquake in Quincy, then it will take us 3.5 days to restore Xbox Live Service in another data center. And this is with a budget of $3.4 billion spent on infrastructure. See? So that's what it is. The reason why that happens is everything is on hardware. They don't build any resiliency. Say, I need clustering. I need RAID. If disk crashes, my application should survive. I need RAID 0+1. I need SAN for data, making sure that data never evaporates. I need dual internet providers. I need power stations which are dual. Everything is dual in corporate world. Okay? So what Amazon did is this. They just basically took custom away from customer. Okay? They just basically said, we are not going to do any of that stuff. It's all your problem. We are going to give you a VM that does not even have storage that is persisted on that VM. So if your VM shuts down, your storage is gone. Unless you want to use Elastic Block Service and start moving stuff there. If you say, they'll tell you we have SSD, and if you use the SSD, it comes as /MNT. That's the mount, and if you use it, if they reboot the VM, and if you don't have a big enough VM, the VM will come up on another machine. That thing is gone. It's called ephemeral for a reason. So you can't even get persistent storage on a single copy. Forget about redundancy and having RAIDs and all that stuff. So what they said is, this problem is yours. It's not mine. And I'm going to give you infrastructure. And what it allowed them to do is do something like this. So this is like, think of it as a canvas. So what Amazon did is bought machines which are big and made it look like a canvas like this. And then what they did is they standardized everything. So they said, in my data center, in this particular array, I'm going to have 18 of these machines. And if you go to Virginia, it is 18 machines. If you go to Oregon, it's 18 machines in that particular array. It's nothing different. So you can basically teleport people, operations around all the Amazon data centers. They can operate exactly the same way. The way they came through with this is how they manage their warehouses. So it's all standardized. Every single Amazon warehouse is standardized. So that's how they started managing their data centers. And the reason they did this is because they managed their IT this way, because they had to reduce cost. So Amazon EC2 was not a genius product that they came up with. They already had it. And the genius part of that was they thought the world will actually need this, right? That's the genius part, not the building of EC2. So what you do is you get that, you layer virtualization on top of it, and your business model is basically arbitrage. How many people understand arbitrage? So it's arbitrage to the rest of the folks who didn't raise their hand is basically you do not know the actual price of what it is, so you sell it at a premium and while buying it at a lower cost, right? That's arbitraging. And you're taking the variance of that change in that, and you're somehow keeping this constant, making the person think that I'm getting a better deal, and actually you're not. So it's like everything in like all the futures are arbitrage, everything of that is all arbitrage. It comes from a stock market process, right? So what they do is nobody knows what it costs to run that machine, how much it costs, what is their operation cost, how much does it cost to even buy it, and they have done everything possible to reduce that cost. So they were buying this from Dell, they buy it from Taiwan now, because they went to the manufacturer of the machine in Taiwan and told them, we are going to buy 30,000 of these every month. Why do I need to go and buy it from Dell? Dell went into a tailspin, right? I mean, that's exactly what happened. And so these guys started reducing the cost of this, just like how they managed their whole retail industry. They did this for this. So it's beautiful. So your data center looks like this. It's homogeneous. There is nothing in it different. Every data center will have the same block storage, the same way, and it's all routed the same. Switches are the same. Everything is the same. So now you can automate everything because it's all the same. I don't need to worry about the switch case statements, right? So then when you buy stuff, it looks like this. So each of those colored things are VMs that people are actually provisioning. So different sizes, they just block it in different ways, and they have all these gaps. And if they have gaps, if somebody says I need a micro machine, you get shoved into that one of those gaps. If you want a 3 or a 4 core thing, they will look at the best possible place where they want to put it, and you're there. And so this is how they run it. So what happens as a business like me, who's trying to run many of these VMs on top of it, I don't get any of these benefits. I just pay the same 7 cents an hour, and I have to pay for it. That's how Amazon runs it. But this was one problem for us, and the other main problem was our whole business was CI, and our differentiation was speed. So how do we actually make this work is how we were, right? So for speed, and I'm not talking about speed as in just how fast your build runs. I'm talking about how fast can we innovate, how fast can we push code, how fast can we actually do stuff, right? So I'm just going to walk through exactly how we do development, right? So think of this as MW is a component of ours, middleware is a component. So its master is the branch of how that component is, and how we do continuous delivery. So let's say I want to make a change to this, right? So the first thing that happens is a developer gets assigned to it. The first thing they do is they fork it, and they'll make a copy of that into there. This is a pure GitHub flow. This has got nothing to do with other Perforce or anything. This is how GitHub works. We follow GitHub. So you fork it, and then you make all the changes you want. So you need a CI machine for that particular developer, because we don't believe in nightly builds. We believe in builds and CI happening every time a developer actually touches anything, right? So that happens, then the developer submits a pull request saying that, hey, I finished my feature, I want this to be merged into master, and another CI gets fired. So what we do is we take the copy of master, we take the copy of the pull request, we run CI on top of it. We don't care whether dev has run it or not. And if it gets rejected, the developer's code goes to the bottom of the stack, and then every other CI happens on top of the pull request. So developers want to do CI before actually pull request happens, because they want to be sure that this thing passes. This is more of a safety check, right? Once that passes, it gets merged. Oops, sorry. I don't know what happened. Yeah. And we push it to pre-prod. The whole thing gets functionally tested on pre-prod. It's still all automation, but it's not just CI. It's doing a lot more stuff. It's really deployed. And if that works, then it gets pushed to production. So this is our workflow. So this happens every single day, multiple times a day. So every single feature is a pull request for us. There is no bunching.
This is fully automated all the way through.
It's fully automated. It's automated based on triggers.
Okay, so there are humans involved and
Not humans involved. So humans are involved only in this stage.
yeah, that's what I mean.
Pre-prod to
That's what I
prod.
mean. Okay.
But up to here is automated. So the
Okay.
moment this thing gets in,
Right.
then what happens is there's a webhook that this gets
Everything
fired.
just kicks off automatically.
Yeah, it's
all the way.
automatically. It's all automatic, but it's just the only thing, the production deployment can be made automatic. It's just a sanity
Safety
check
check.
where we say, hey, somebody
So
is actually doing it.
Pre-prod is the same hardware, same setup, everything is prod.
As in the topology is the same, the hardware sizes are not the same. We are not doing stress testing in pre-prod.
Okay.
We are
my
based.
next question.
Yeah, I mean, that's the whole workflow. Like what we do is we basically have benchmarks saying that if my transaction, which is this, takes X amount on this hardware, then it will actually take this amount on production
Yes.
also. So it's just all extrapolation. And if something doesn't work, we'll go back and change the equation here so that we can kind of figure out what that limit
Is
is.
that pretty predictable?
Very, very predictable. It's very, very predictable. And so now think about it if I have another developer. So this is our problem. Forget about how Amazon runs it. Now I need a VM for each of this. So I need 4 different VMs, or I need 4 different Jenkins workers, right? I need 1 master and 4 workers. Now all of these are VMs traditionally. Now you could say, hey, I can run 2 workers on a single machine. But then the problem is you don't have consistency anymore because one developer's code could have changed something which another developer's code is relying on. So I need the machines to go back to 0 before I can actually build this back up. And if both developers are doing, you're going to start queuing these things. And builds, if it takes 6 minutes, now second developer gets feedback 12 minutes later. So all these things slow us down. So our thing is you got to have VMs for all of these guys, and then you got to be able to make this work. So if I now take the cost, the machine that we were using was M3 medium. If anybody has used micro or small, tell me if it actually works. I want to switch, right? It never works. I mean, if you try anything, it'll just die in about 3 minutes. It'll just die. And especially if you do any CPU intensive stuff, they throttle the hell down on this because they don't want you to be on that 4-cent machine. They somehow want you to be on slightly higher. So with this one, it is $150 a month. So it's $50 a machine, M3 per month. And even with today's cost, this was much higher for me because Amazon did 2 price cuts since we actually did it in last March. This is based on today's price, it is still this, right? And then we have 8 components. We have middleware, UI, status update, notification, database, whole bunch of stuff we have. So I need a total of this for just build machines. We have not talked about pre-prod or anything. This is just those 3 CI machines per component because pull request is a common one. So I had 2 developers on each component, so 3 machines, $50 each machine, 150 times 8, 1200. So this is a ridiculous number for a startup which is not funded, right? I mean, this is where I think, okay, this is crazy. And Amazon gave us $25,000 of free hosting because we were part of Techstars, but it was still too much for us. And so we kind of were thinking, what the hell is this? And then if I look at total infrastructure cost, this was what it was. Builds costed me about $1,200, pre-prod was about $800, and prod was $2,000. And this is based on the load that we had at that time, which was about 800 VMs, right? So, I mean, 800 kind of stuff we were doing, and then the way we did it is arbitrage. We were imaging VMs, we were doing all that stuff. There was a lot of engineering work we had done in order to make this work. If you give them dedicated, I mean, this was very similar to what Travis does. Travis uses Vagrant to bring up VMs, and that's how they actually do it. So the key part to note here is the number of machines. It's not the cost here. This, a lot of startups will say, I don't care. But the problem is that I had 24 VMs, 16 and 20. So it's about 60 VMs at this scale. And for a startup which had only 4 people. So it just starts becoming very unmanageable. So it was about $4K a month. Right? So August 2013, Docker comes in and they start saying, okay, here's what our value proposition is. I drank the Kool-Aid first and I looked at it, and I didn't drink the Kool-Aid because it was cool. I drank the Kool-Aid because I was spending $4,000 a month. And I said, I have to do something about this. And I have to be, I mean, because I do 1,600 containers, I go the next double. I mean, it's all linear, right? Everything is linear. I was not getting any benefit. So basically what we did is this. So we took the same exact concept. We said, okay, Amazon does it this way. So that's where we did a lot of this thinking. Then what you do is you provision the biggest VM possible, right? So you become the bully on that particular physical machine on Amazon. So you buy, we bought at that time 2x large was the biggest one. Now I think it's 8x large. I think at that time it was 2x large. We said provision 2x large. And then that's, once you do that, you have some weak space there, but you really can't fit any decent machine there. So it's all going to be these micro things, and we know anyhow they're going to get throttled down, so we get all the resources. So we don't worry about noisy neighbor issues, right? Then what you do is you layer Docker on top of it. Okay, so now what we are doing is we are beating Amazon at their own game, right? You layer Docker on top of it, then you do this. You run containers on top of it, right? Now I get all kinds of stuff. Now I get one copy of Ubuntu on that host machine on a VM and run containers on top of it, and I can do anything I want, right? So what ended up happening is, if I look at our production, this is how it looked. You remember those 20 machines in production? This is how it looked for us now. So we had two big machines. Those were 20 large machines there because production was large. M3 mediums was what we used for dev and test, but production was M3 large. So we had this, we had two big machines, and it costed us $600 a month in total. And I had 10 containers running on both, and our utilization on this was still less than 30%. I could actually double this, and I would still be on the same thing.
$600 dude.
$600, that's what it was. And the biggest number is the two, right? Our infrastructure cost, which looked like this, went and became something like that, right? So we went from 1200 to 300, 800 to 300, 2000 to 600, right? So this is the cool part that happened, and we got all of this, which is portability. So I could take my middleware container that's running on one machine, and I want to bring a new version. We stopped doing deployments. What we would do is we'd bring up a new C2 X3 large machine. For 1 hour, you'll pay that extra 65 cents or something, which is totally okay with me. We would bring up a whole new container set because it's all portable. And then we would just decommission this. Better yet, this is the part which is not in the slide. What we would do is, in case one of my nodes go down, I would actually provision 3 and stop the machine, right? Amazon doesn't charge you if you stop the machine. So you pay that 65 cents to do the deployment, and then you stop it. And then you wait if one machine goes down. And if it goes down, in 30 seconds, I can bring this machine back up, and I don't even try to go and figure out, no debugging. Just start this machine, you got your two things out, provision another machine, you terminate this machine, deploy again, and you're back to normal again, and you again stop it.
Awesome.
So this is what it gave us, and it gave us all the portability, and then it gave us layering of images. So that meant I could actually go and write on top of images. How many people have tried doing AMI snapshots and all that stuff on AWS? You know how long it takes to do a simple snapshot? And the worst thing is I can't move it across availability zones. It has to be within the availability zone, right? And they talk about all disaster recovery and everything. How do I move this AMI? And then you have to pay for network bandwidth because you're going across the whole thing. All that stuff happens. Now let's assume you have a snapshot. I want to change one single file in it. What do? You actually first instantiate it, SSH into it, change the file, and do the whole snapshot again and keep another snapshot.
Yeah.
In our world, it was just layering. I didn't have to do anything. I just had to go into the machine, SSH it, and say commit this container. It got layered on top of the prior container. So let's say I had abc.txt, and I wanted to rename abc.txt to xyz.txt. So the image first, if you bring up the image -1, it'll always be abc.txt, and I layer that with image +1 or image tip, we used to call it tip, and then that'll rename it to xyz.txt. So it was all layered up, right? We had a limit of 42 layers, but at 42 layers, if you're still patching your container, something is really wrong. I mean, you might want to kind of rethink your patching strategy. So it gave me that. My spin-up time of a container was 4 seconds.
Nice.
Right? And that included all the application also. It was not about just spinning up a VM. I'm including the whole application, all the code is there, all settings are there. I just need to say start, right? And then it was build once and run anywhere. Now I could just take that container and say clone it, and I can get 5 of it. And then I can move it into 5 different machines. I can do all kinds of stuff on it. And the most beautiful thing is I didn't put it here because I didn't want to create too much chaos. Our snapshot machine was on DigitalOcean. So what we would do is we would push to DigitalOcean and pull it from another availability zone and bring it up there. And all of this can be done because your container size is just 200 megs. Because the Ubuntu is on the host. It's not part of your snapshot, whereas AMIs have the host in the OS in it, right? So as long as I have both the machines on both sides of my availability zone having the same OS, I can move my containers across availability zones in a matter of seconds. So our disaster recovery, moving from one AWS availability zone to other, is exactly 7 minutes. We are way better than Xbox Live, and we are a startup, right? So that's all the stuff we got. So if you looked at it from a summary perspective, it was $4,000 to $1,200 per month. And this $1,200 is actually today's cost, and we run 4,000 containers. And it's not what I would have needed if I was running 800. So I have gone up by 5x in terms of my workload, and I have dropped my cost down by 70% based on today. And we are still running less than 32% utilization. So I can still double and still be at the same cost. So that's basically where we are trying to go. Right? But that was, okay, this is the AWS bill or AWS cost, right? What it was this, which made a lot of difference. Now instead of managing 60 VMs, I'm managing 6. Right? Now that is much more manageable for a 4-person startup to say, I'm going to manage 6 VMs in the cloud. If anybody has used RightScale or anything like that, per machine, I think they charge you $50 or something per month. So if I had 60, I would pay them $3,000 just to monitor those applications.
We used them. We finally got over using them, but yeah, it was just crazy.
So I think that's where all of this gamification starts coming in, right? So what I really want to talk about or leave you with is basically how we built the fastest continuous deployment platform on AWS and trying to game them in such a way that it's to our advantage. So what we are doing right now is 4,000 containers. They were all VMs at one point. So even if you say, I bought the cheapest VM, let's assume that you ran it on a micro, right? That was about, what, $15 a month right now, or $12 a month, something like that.
15, 17, something.
Yeah, something like that. I think it's 15, I think. And if you look at that, at 4,000 containers, that is $600,000, oh sorry, $60,000 of revenue, about almost $500,000 per year. That's what Amazon is kind of, we have gamed them from what they were trying to do. So that's basically my talk. Any questions? Anything that I can talk about?
Is Bezos pissed off right now with you?
So actually, it's very ironic, right? Today, how many know Active State? You know a company called Active State?
Staccato.
Yeah, Staccato. So their main guy, I think his name is Goldberg. I don't know his first name. I think it's Steve Goldberg or something. So he's considered to be like the 10 most influential people in cloud. And he wrote a blog, and I didn't know about it, and somebody sent me a link today morning saying that he wrote a blog about it. And if you search on Active State, you will find the blog. It was about this talk, and he had almost half a page of this blog about how Amazon is going to go into this weird state and what they need to do in order to recover, which is basically destroy their EC2 business and support Docker, which actually will mean something very, very radical for the cloud world. So that was what he was trying to write. And I think we are kind of scratching something interesting. So what we ended up, once we started looking at all of this stuff, what we ended up doing is, look, our workflow is cool, our software development process is very cool, we want to do all this stuff, we want to give you CI in the cloud that continue to run as a business. What we are doing right now is working with 3 very marquee customers, and we are giving them our whole software to run on top of AWS so that they can do exactly what we did. And they are running 700 containers or 700 VMs on Amazon. And they are trying to layer this whole software and run our workflow on top of it. Because you can actually do it. I mean, everything, we have built all the plumbing of how to manage it, how to do delivery, how do you spin up new containers, how do you move containers across. We have done all of that stuff because we needed it. So that's where I think we are trying to go. And CI is definitely one part of that solution. We will continue to do topology-based testing. We'll continue to do stress-based testing, to your point. But it's all going to be that entire software. And stage 3 of the company would be, now you can run that on your own premise. Why do you need EC2? You can actually run it on physical machines running inside your data center behind a firewall.
Could you talk about the use case where you spoke about like the 2 developer scenario in your pre-Docker implementation, right?
So that is our current scenario.
No, I think.
So you're talking about this slide, right? Wow.
Yes, this slide.
Yeah.
So I think you focused on this in terms of the pre-Docker scenario, the number of VMs you had to support,
Yeah.
right? How does this scenario play out in like the post?
So now you think about it as this whole up to this point, this was a whole dev and test for us, and this is pre-prod and this is prod. This, if you looked at the calculation, we had 24 VMs to do this thing for 8 components because 3 VMs per machine, and we had dropped it down to 2 large VMs. So everything was done on container. So instead of giving every developer a VM, we started giving every developer a container. And that basically resolved our problem of having VMs proliferation. And now what ends up happening is when you create this master and somebody forks it, they automatically get a container automatically. It's all part of our workflow. So just the way you fork it. And another thing which I didn't talk about, because this talk was not about how we do development. So the way you create this project is through a chat room. So we don't even allow people, I can talk about that on a different day because it's a bigger topic. So everything happens is what happens today is people end up going and saying, I want to create a project and then I want to build a team and then I bring the team in and suddenly you say, I can't talk to these people, I'll go create a chat room. And either it's Campfire or it's Basecamp, HipChat, IRC, whatever you use, that's how they do it, right? What we do is exactly the reverse of it. So when I want to create a new component, I go first create a chat room. The moment I create a chat room, it automatically, the name of the chat room will actually create a project on GitHub. And I become the owner of it. And then I will invite anyone out there. I'll invite Sanjay into it, and then you will get added, and then it'll automatically add you as a collaborator on GitHub. And then because you got added and you can fork it, you will get a container done for you. And it'll automatically fork that project into your personal repository. So now you have your whole dev setup done. And the container is coming from a base image that we know has to run on this. So there is no question of developer telling me it works on my machine. If it worked here, we know it'll work here. Because it's the same exact container. It's running on a different size. It's different memory footprint, but it's exactly the same container.
So you said you're running 4,000 containers now, which otherwise would have been VMs. So I assume your customers are also running on containers?
Those 4,000 containers are not our containers. These are all customer built containers.
Right. Because
so we are running only
like
about 60.
And then so the software you guys have developed is around managing all that stuff?
Not managing, the whole workflow of how do you provision it, how do you manage. Think of it as like saying today what the scenario is. Let's say I have a 50% development organization and I need to create dev and test and pre-prod environments for all of this stuff. So how do I go about creating that? So what we basically say is it depends on how isolated do you want this. So if you say I want these 3 to be on complete isolation, you need 3 VMs and you layer a fabric of Docker and you create all that workflow, and then you layer all of these workflow things of how do you move this pipeline and everything. So Docker is still a technology that we use, but it's all the workflows that we have built on top of it, which is what is the software. So you can say, I am in a very early stage, I really don't need isolation, you can just pick one big box and then do dev, test, and production on the same box. And the containers will give you the isolation that you want.
So the automation for that whole workflow and process and stuff is what your software actually enables.
So today, let's say I'm running 20 VMs on EC2 because that's what I need for my dev and test. You can pretty much come and say, hey, I'm going to use this software on top and I'm going to collapse that to 2. And I can still get my 20 environments because I can use containers to do all of that stuff. So can you do this all yourself? Absolutely. You can go build Dropbox yourself too. Yeah. You can, right? It's just files there, and so that's the
value proposition.
That's the value proposition,
right? Do you control what the dev host box is your container sitting on?
Can you control this?
No, the thing that you're going to put that container on. So the developer.
So this is not on a dev box. This is on EC2.
So when he clones it.
So they can actually run a copy of this image on their local machine too, but we don't care about that. You can do whatever you want on your dev box. You can run it on a base Ubuntu, you can be on a Mac, you can be on anything. But this CI will run on an image
Okay.
that exactly is the same image as this and this is. So we know that if it works here, it will work here. And if you have done CI here and your coverage and what do you call test counts is good enough, then we know that you have covered enough so that you can actually go through. I think you had a question.
That sort of leads into my question. It's like on a development box, you have like VirtualBox running on your Mac. You have like Ubuntu on there, and is it the same Docker?
So if you use boot to Docker, like I can see whether I can do it. I don't know whether I have not used this machine, so let me try it.
Maybe conceptually, it's like,
Yeah, I mean I just want to do B2D less. Yeah, I think it's dot.
Can you zoom a little?
1 second. Yeah, I think let me control command plus plus. I think. Is that better?
Yeah.
Okay. So basically, what I have is a boot to Docker, and I can do an init. And VirtualBox already exists. It's a VirtualBox VM, and then I can just say boot to Docker start. It's usually about 5 to 8 seconds. I don't know whether if any images have been updated. So this is a really old one. I have not used it, but it should start pretty quickly. So once it starts, I can actually SSH into it.
and then if you notice, like maybe your libxml.
Yeah, they're actually. Sorry.
If you notice there's something wrong, like you need to update some package on Ubuntu, like libxml is old or something like that.
Yeah.
You just update it on there, then get a new.
So I'll show you exactly. Let me just do it exactly how I would do it. I would do then boot to Docker, SSH. I think it's TC user. Yes. So this is completely brand new Docker machine. So I have Docker on it. There is everything. This is Ubuntu base, and I can just do Docker images. There is already an image out there. So I can just run, this is the image that's there, and I can just do Docker run -i.
Wait, so inside your.
So I'm actually inside boot to Docker now. So there is a host machine that I am on,
Okay.
and I have a Docker image. I can do something like Docker pull.
Boot to Docker is like a very tiny Linux.
It's a very it just gives you, I think, 3.6 kernel, and it just gives you Docker, and that's it. I have everything, so I can do Docker pull something like b shippable / I think min. Yeah, we are really trying my memory here. Min 01 base. Yeah, actually yes. There. So I'm actually pulling the base image of my system.
So
So
you
the-
have that in GitHub somewhere? Or?
No, this is in Docker. So it's pulled to Docker. So I'm actually pulling, I'll bring up this whole instance and I'll show you what it is.
Is boot to Docker a Vagrant image, or is this is that
No,
also
boot to
image?
Docker is basically a lightweight Linux kernel layer, which will bring up enough stuff for you.
But is that also a Docker image, or is that another VM?
It's a Docker image.
It is.
So it's basically a Docker thing. And then what they're doing is they package it in a different way so that you can actually install boot to Docker on your Mac, and you can actually bring it up, because Mac doesn't support natively Docker. So I pulled it, so it's, yeah, this is about 500. So it's pulling Ubuntu 12.04 base image with Node and Python installed on it. That's what it's pulling.
And those almost look like commit.
So these are all layers. So all my layers of my image, I can show you the Docker file of what that is. And once it finishes, then all I do is, I think based on this. So what it's doing is, it installed, these are all AUFS layers on top of how it's actually layered. And so I'm pulling the final layer, which is about 580 megs. And once that comes in, now I have an image on which I can run as many containers as I want. And once it finishes, I'll show you how to start a container on top of this. So the way all of this memory is, like, if you think about it, I don't have any apt get installs and all that stuff. So there is consistency between every single machine I run. So just the way I do this, I can be on 2 machines on 2 different availability zones and run this exact same command. I got exactly the same base image on both the machines. I know it is consistent. and a developer would have already done this on their machine, and they run their, like what I am doing. So like assuming this is my dev machine, I'm pulling an actual machine image that my CI system is using onto my local machine. So if it runs on this container on my local machine, there's a high chance that my CI also will pass. So what ends up happening is all our devs have full infrastructure running on their laptop with all the containers. All the 8 containers are running and they're all talking to each other. So when they make a change, they actually run full end-to-end functional tests on their machine. Not just about I do my unit test. It's like fully done. UI can be logged in. The whole shippable is running on their local laptop.
Do you have any success in creating a Docker image for, say, Ubuntu, but deploying it on, say, CentOS? Is that
You have to create a CentOS image.
Okay.
So Docker supports, I think they don't support CentOS, I think because of they use C groups. I think that's what the Red Hat initiative is, that they are actually doing the C group parts, because this supports LXC right now. So if you use C groups, then you need that, and that's what Red Hat is working on. And I think in Red Hat Origin, you can actually do it right now.
Okay.
There's no reason we can't use Ubuntu. We could switch from CentOS. It's just might pick it up.
That's just a curiosity.
So let me restate that. Maybe I answered it too quickly. So if your CentOS is the base and you pull this image, what it will do is it will actually pull the Ubuntu image on top of it and run a container on top of that. So the CentOS is just used to run Docker. That's it. So it's not using anything at the CentOS level. It's using this particular image, like it's almost done. So everything that the container is running on that file system.
Mm-hmm.
Docker does require like a later kernel. There are some features that it requires which are more.
It's just .32. .32 or greater, I think.
Yeah, I don't know exactly which one, but I had to upgrade some of my boxes to be able to use it.
And you said CoreOS, that's like almost a competitor to the
Boot to
Docker.
It's to boot to Docker.
Okay.
So they're still, I mean, CoreOS comes with 3 things. They come with etcd for any kind of daemons, and then they come up with Docker, and then they come up with, I want to say, I don't know what else they come with. They come with one more thing. So those are the only 3 things that are available. There's not even apt-get. What's that? So, okay, so if I go to Docker images now, so you will see that new one that came in. This is the new one, min-base 01. So I'm going to run, maybe I'll pull this up a little bit. So I'm going to run Docker run -i for interactive. I'll just say shippable / min-01 base, and then I want to get into bin/bash. So what it's doing is it's basically starting up a container for me, and hopefully it should start pretty quickly. Shouldn't take this long.
You don't need the T switch?
Oh yeah, that's the tag. Sorry, I missed it. That's why. This is -t. Yeah, that's how fast it should be. Sorry, thank you. So basically what I have now, it's very interesting, right? I'm on my Mac in boot to Docker in a container. So it's kind of, you very soon get into inception issues. Like you don't know where you are and what you're doing. So if you look at this, I can do ls. This is my root. And I know that it has shippable account, so I can do sudo -su or sudo su minus. So all my code, everything is already there. So my entire deployment is already done. So now I have this one second before that. So the cool thing about this now is if I exit out of this and use docker ps, there's nothing running because it stopped. If I do -a, you will see that container that was just latest 58 seconds ago. The other one was still there, but I just couldn't get into it. So that was done. So now if I had done anything I want, if I had done any changes, I can just commit this container. And then it will create a layer on top of your layer. I can then say docker push. Now suddenly my main thing got updated, and I can do docker pull on my other machine, and that thing came into that machine. So that whole workflow is what it is.
So,
What about the IP addresses? Like what?
So it's doing multiplexing. So what it's doing is it's basically using my physical card onto boot to Docker, and then it is creating a multiplexing of all the things. So the beauty of this is each container has full ports, everything available. So one of the coolest things is if you're running 8 machines for 8 developers and they all need port 80, it's available for you because now